And thank you very much, and a good morning to you all, wherever you are. It's a pleasure to be here. It's nice and sunny here in Singapore. I hope you're seeing the screen very well. If anyone is not, please do say so now. Otherwise, I will then continue. So, in the next 45 minutes, we are going to continue with the theme of artificial intelligence, but this time we're going to take a much closer look at how we use those platforms to development of the resilient, smart, and sustainable cities that are all critical for the future. And really, now we're at an inflection point where this is the time to make the transformation because of all the environmental factors that we see with growing populations and pressures. So just a quick introduction to myself. My name is Martin Yates, as was introduced. I have a great team here based in Singapore and some people around the world, and what we do is we help architect the smart cities and digital cities of the future. We help support governments on developing their emergency services, building integration operations centers, how to architect the cloud models that they need to be able to underpin those, and embracing all the newer technologies that we see around that, such as 5G and IoT edge, artificial intelligence, and more. And I really just would like to sort of share the vision that Michael Dell shares, is that he always has this views that we share a vision of the future that's always better than today. And I think that's very important, that we don't stop at a single moment in time to continue to improve. And I'm based here, as I mentioned earlier, here in Singapore, and I help the government on various different standard communities, whether that's cybersecurity, community and security development. We've also produced some interesting books around cloud security and cloud native standards for things like Kubernetes and things, so do take a look at those books if you can. So what's this all about? I think we've all seen the pictures from around the world where if you allow a city to develop in an unchecked way, it grows, more and more people are coming to that city. It puts huge pressures on utilities, the electricity, the water, and all the different resources. So people tend to build higher, and pollution, as the city density transport becomes more condensed, pollution really sort of ramps through. And you start to sort of imagine and start to see these cities of the future that really are not great places to live, somewhat almost dystopian. And we realize that at this time in history, now is the chance that we can say, using our know-how, using our technology, using the latest techniques in building and planning, with good governance, we can build a more utopian society, a more utopian place to live. And this is what drives us every day, is to build those beautiful places to live in our future. And when we look at the journey that people are taking and planning for, and have already been on that journey for some time, we see that essentially the cognitive cities are core, right? The ability of a full intelligence end-to-end city. But at the same time, zero waste. If you look at somewhere like New York, that has this very clear vision in quite a relatively short time to produce zero waste. Or perhaps you might want to look at Sydney, which is what they call the 60-minute city, which is all about being able to get to anywhere across that city within 60 minutes, rather than very large delays. And when we focus here on Singapore, we regard ourselves as a whole of society. Everyone is included, government and people together, integrated together under a digital platform. But of course, paperless journey has been something that everyone has aspired to for a long time. Government typically tends to lag the commercial industry. But again, we see, if you take, for example, UAE and its paperless journey, it shows that it's absolutely possible to have that vision of a complete digital world. And finally, if you look at amazing projects, some of the ones that we've been looking to right now is the autonomous city, which is Woven City in Japan, which is a Toyota vision of the future, a model of how the world will look when it's fully autonomous. And so these are great cities to take a look at as work afterwards, to see, when we think about AI, what are you really trying to apply this for? What are you really trying to deliver there? And so we see and we know that that requires that intelligent infrastructure, requires that 360 awareness, because if you cannot measure, you cannot manage, and it's always been like that. But also the world is full of different emergencies and critical times where you need a good way of managing crisis, and we've seen that, of course, in the last 2 years in particular. And other things around things like such as predictive policing, again that's an AI core, distributed energy, smarter energy, autonomous mobility is rolling out across the world at different speeds. Right here in Singapore we have all sorts of autonomous mobility, be that buses, be that taxis, all types of service and robotic systems as well. And so these are just some of the things that we see that are really allowing that foundation to be sort of created and to be delivered for those cities that want to be able to be part of that new future. As an example, again, as you know, Singapore, and I'm sure that most of you have been to Singapore, we are a small country, and we realize that we can only win when we work together, and we must be innovative every day. What we did yesterday, we can celebrate, but today is a new day, and we have to start the innovation process again. So we never stop innovating. And that's why often if you check in any number of different reports, you'll always see that Singapore is the #1 smart nation there. But it's not something that is given by default, it's something that has to be worked for every single day. Now, it's very interesting because I'm, as a person, I'm really a big technology person. I love technology. I live, eat, and breathe it. I probably buy all sorts of things that I shouldn't do, from the AWS, etc., on different devices and IoT devices. So I'm fascinated by technology, but the reality is the world today is not looking to technology. And I use this beautiful quote here that says, people don't want to buy a 1/4-inch drill, analogous to the technology. They want to buy a 1/4-inch hole. So this is really all about the outcomes and the KPIs that people are looking for. So myself as a technologist, I always have to look very far into the future about what those outcomes are going to be looking for. So when we start an AI project, of course, we're always mindful of what that outcome needs to be and how quickly that might change. So these KPIs often can be moving targets. Now, my intention is not to go through every line item here, but what do we mean by cognitive outcomes? And again, if I give you some examples here of where we've applied AI, for example, it's all about developing that citizen satisfaction. Happy people is very important. How do we know that we're happy? How are we measuring that? But of course, a country survives on its business. So are we measuring our business effectively? Are there people saying this is a great structure to build a new business, to be able to innovate and to be able to expand with staff? So again, the stakeholders of both the business and citizens are absolutely critical. You've got to have ways to be able to measure that. But of course, the ability for e-payment services, the ability to exchange contracts that are signed and sealed, and exchanging of information are also critical. As well as, of course, the number of transactions from end to end must be digital. At no point should they escape into some form of paper or some form of email sort of tick box. So we really need that whole payments life cycle, that whole transaction life cycle, to really be part of an endless stream. Digital capabilities, and here's a good point, you see, because we often talk about how government should use artificial intelligence, how they should use big data. But what you end up with is a very small number of people that know, data science, that know how to apply that know really what it means. And it's incumbent upon every one of us to go out and be able to enable people on big data and AI, just as these great sessions are doing right now. And so really we've sort of put KPIs in the ground that say, that X number of thousand of civil servants must have some understanding of big data and artificial intelligence and how they can apply that. And so that's really part of the journey. You cannot be an elite set of digital natives. It must be, everyone must be part of that journey of transformation. Otherwise, you get a disconnection in terms of the journey. And you often can get rejection. So people, if they don't understand the technology, they may reject the technology. So it's very, very important. And of course, when we really super zoom in on that AI and that data analytics side, it's important we set those KPIs as well. On the ministries must be using AI. They must have high impact outcomes. And there must be a good core and understanding of many of the services must be able to use machine readable formats and APIs to be able to exchange information between different government entities and different businesses. Because without that, you end up with silos of data that are hard to convert. So it's just some of the things that really is important in terms of defining that journey. As a CTO myself, we receive requests all around the world from different people wanting different things. Essentially, before we even think about the technology, typically these are the KPIs that people are looking for. They want their city to operate more efficiently. People want to feel more safe. The energy has to be well maintained and predictive, where emergencies are handled really, really well, no matter whether that is road accidents, whether that's climate change type incidents, hurricanes, typhoons, all these kind of things. Emergencies need to be managed better and better because the world is getting, unfortunately, more and more of these kind of climate type change. But of course, building smarter industrial states to build and attract client to that. Smarter healthcare is at the center of any good national policy. Building that, being smarter, and more importantly as well, using predictive and AI technologies to keep people out of hospital. I mean, that's really the point. I mean, hospital is your kind of last point. Really what you want to do is keep people more healthy and happy so that they don't have to come to hospital in the first place. That's one of the key areas that we see as really important. But again, good transportation services, simplified government, huge pivot in the last few years on green and sustainable. So how are we best using those wind turbines, solar energies? What other technologies and energies can we use in terms of providing a more cleaner and sustainable environment? And artificial intelligence has a long way to be able to provide all sets of different services behind that. And I could literally run a whole session on just the clean and sustainable environment and technology and where that fits. And also more efficient food production. Food is becoming more and more difficult to produce. There's less and less land, and therefore we have to look at smarter, more better agricultural ways to develop food. And here in Singapore, for example, we have a number of different strategies, even though we're a very high density city, to grow our own food. And we're looking to be able to grow in the next few years 30% of our own food using techniques such as vertical farming. And all of this will require very advanced technology to be able to support that. Everything we do now, we look at that and we say, where do we as ICT professionals fit in the United Nations Sustainability Goals? Because these are the core ones that we all aspire to and our governments are signed up to. And I guess the most common one is really SG11, which is about the sustainable cities and communities. But of course, there are other areas as well, whether that's on the climate action, life below water, life on land in terms of smarter crops, etc. And being able to produce more affordable and cleaner and greener energy. They're just some of the areas that we need to look towards when we think about how we're applying artificial intelligence and digital technologies. So all of the examples that I gave you earlier, they're all underpinned by those technology drivers. The 5G is becoming a very, very large driver now, but edge, AI, ML, big data, cloud, and security, these are all core drivers. Today we see a mix of deployment models of these technologies. People use their own data centers, enterprise cloud models. People like to start using telecommunication companies. So many of our customers around the world are telcos, and they want to stand up their own services. They want to deliver their own agricultural service, their own healthcare services. So around the world we have numerous customers in that journey now because they've got great networks, they've laid out their fiber optics, they're deploying their 5G, and now of course they want to monetize those services, deliver those value-add services. Telco has been a huge, huge focus in this last 1 year for smart city and digital city application. But of course the local cloud service providers continue to take a role, as well as the global cloud service providers as well, the AWSs, the Azures of the world. And so all of these models that I put here in front of you all are part of that fabric in terms of being able to deliver the right kind of services for the right type of use cases. And probably my most important key message that I can always give to you is, whilst it's great to develop all these different use cases, it's very easy to rush ahead and deploy in one particular way or another way. what is really important is to build an underlying framework, a message core, a message network architecture that allows the different data types to be exchanged at speed in real time. And as more and more devices get attached to networks, we need faster and faster digital framework, network frameworks and meshes as that backbone. So in keeping with what I really just explained, this is exactly what we're really seeing here in cities. We're seeing increasing use of cloud computing. We're seeing vast numbers of IoT devices being deployed pretty much everywhere across a city or across a nation. But what we've also seen is that with all these devices creating so much data at the edge, we realize that not everything's going to go back to the data center, and a lot of things are going to have to be processed at the edge. So we call that the city edge analytics. So we see with the growth of IoT, we also see that people need to be able to provide effective platforms for doing edge analytics. Now, of course, the whole topic of this event is really around AI, and of course, the faster and faster adoption is taking place in the AI, ML, and DL space, and that's all, of course, applied to those analytics that you see there downstream. A big pivot in the last 1 to 1.5 years has been digital twins. And I'm sure you've all heard of digital twins and what their importance is. I'll talk about that a bit later. But many of our clients today are saying, when you build and plan my city, when you build and plan my business process, can you make a twin of that? A replica model that allows me to test and simulate and build to speed up my business process, to speed up my development time, check things out before I even implement. So digital twin has been really key in many of those conversations that we're having. I'm very excited to share a bit more with you later. Now, a lot of people say to me, what's this quantum computing? I'm absolutely excited about quantum computing. It's going to be a huge game changer in so many areas. It is a little bit further out in terms of mainstream adoption, but do keep an eye on that because, you know, as this is an AI forum, right, that we have, quantum computing is going to be very, very important in that whole space. Absolutely game changer, and so very excited in that space. It's going to be a real big effect in many different areas, whether that's financial, manufacturing, and even cities themselves. Now, what is really important, of course, is to have still to focus on that data management, focus on the data privacy, look at the exchange mesh that I talked about, those network fabrics. But everything you do, everything you go out and deploy, think security first, right? Because it's easy to deploy things digitally with different firmwares, with different softwares inside, etc. But in reality, you have to keep that under control because those are kind of cheese holes essentially that allow hackers and malwares to be able to exploit. And we see blockchain as being really critical as part of that. And so we're using a lot of blockchain now to be able to secure industry and to be able to secure cities. And I mentioned earlier that, you know, green and sustainable is pivotal as well. Now we're looking to all the technology we implement should actually align with the UN sustainability goals and should be as green as possible. Again, I won't go through this whole list, but what we have seen is this traditional IT and traditional closed standards have moved away now. The world now is based around microservices, implementation of 5G services, containerization models such as the Dockers, Kubernetes of the world, cloud, AI, ML, agile software development. There's no point doing software development if it's not agile anymore because you need those results faster. I call it bigger data because the data just gets bigger and bigger. Analytics at the edge at speed, critical, software-defined everything, digital twin, supervised aggregated IoT edge, AR, VR. We're seeing huge demand for AR and VR right now across our client base. Not forgetting that blockchain and that quantum computing. So the kind of KPIs that we receive, we don't get requests for actual technology directly. We get requests for environment. Can you improve our water quality? Can you improve our waste management processes? Can you provide better air quality management? You know, because we want to reduce by 1 or 2% of this or this. But also help us think about how we can grow our city, how we can engage our citizens better, how we can deliver better mobility across that city with all the different KPIs that you see here. How can we do our public safety better? What are the key priorities? what are the budgets that we need to be able to improve that, whether that's smaller things such as the jaywalking, but more important things like crime deterrence and response times to incidents. And finally, of course, that all-important digital government. It's great to be digitalized everywhere, but the government must be there, right? And that whole journey of government, population, identity management records, seamless government, that's all key part of this digitalization of a country's future. And if people are really not focused on these parameters in front of you, then you're going to really fall behind, whether you're a business, whether you're a city, whether you're a whole country. So when we've implemented different solutions across the world, we've just given some averages here, and it does vary from city to city depending on our implementation. But we have seen, for example, 30 to 40% reductions in crime, the reduction times in commute, 15 to 20% is actually quite achievable by using smarter traffic systems and being much more predictive. But of course, that all important reduce the pollution, the greenhouse gases, keeping people out of hospital, treating disease better. We've seen significant improvements there. And probably one of the easier and nicest ones where we see a real change is doing business with government services, digital government services. Has had significant effect on the KPIs that the government was looking for, but more importantly, citizen satisfaction. Now, out of all those endpoint outcome KPIs, it was all about, when you look at your model, when you look at your architecture model, am I fully automating? Am I maximizing computer vision? Am I maximizing GIS technology, digital twin? What about my data lake? What about my data warehouses? Am I using predictive analysis to the full? And even are you using prescriptive analytics? I won't go there today because that's a really great topic, but to be able to, beyond predictive is prescriptive, where already the answers and the best paths of action are already decided for you based on the data before. And of course, data privacy and security, we've seen the malware attacks. And the other one is the open data portals, where data should not be kept in secret unless it really needs to be kept secret. The more shared data, the better it is for the world in terms of being able to develop business capability and smarter cities and smarter citizen outcomes. Our learning and implementing platforms across whole of government, it was great that we could see that you could have smart buildings, smart homes, you could do things in silo, and that was interesting, of course. And I mentioned earlier how important it is to put that together as a mesh network. But it's very fast and easy to do smart things. But what it's not so easy to do is, don't forget that as you implement smart water, smart transport, they have to be linked to more legacy systems. Large government systems, taxation systems, land registry systems, they're not so fast to move, they cost a lot of money. So you need to see, as part of that journey to bring all your smart stuff to life, how do I connect with the traditional government systems that I have? Right? And that's really, I don't really ever see a true smart digital city until I see a lot of those systems being integrated with the core government systems today, or what I call the systems of record. When we look at the projects around the world, and I'm sure many of you will be involved in, you've seen the kind of projects: urban development, mobility, wellness, education, smart government, and they can really start at different points. Today, the entry points we see is here, number one, which is people want to build a safe city, or they want to do something like build a smart campus, or there's a particular agency in government that want to modernize. Maybe it's the Ports Authority, maybe it's the airports authorities, things like this. So we're often start with these vertical use cases in many cases. However, quite a few of our customers today come to us with that end-to-end. They said, this is my whole city, I want you to modernize end-to-end. And we see a split in projects. There are the greenfield projects and there are the brownfield projects. So the greenfield ones, of course, are much easier. Brownfield ones are always a bit more challenging because you have to deal with existing information architectures that have been installed in the last few years. And in fact, many of the decisions may have already been made about what you need to have. So you've got what I call the in-flight projects. You need to build that and integrate that into it. But sometimes we see there's a requirement for building those smart provinces, those smart states, so that cities, so states filled with cities, and they want to build top down. And very often we will get involved as well with what does a smart nation look like? You know, what are the systems I need to be able to interconnect? What are the APIs that I need to connect city to city, city to government, yeah, and city to citizens? And so that is a much more interesting project, a much more long-term project about that whole smart nation planning. And it takes many years. There's no one overnight thing, but it's very important that you have those good frameworks in place. So here the background you see is a portal. I'm not doing a live demonstration today, but normally I would log into the Singapore portal and you'd see all this data come to life. Our cameras, you know, the number of beds in hotels, the number of hospital beds that are being occupied, etc. So this is all powered and driven by data. And that really is for us where we really want to be. We want to be able to have that complete 360 view. And as I mentioned earlier, I mean, Singapore very much is a brownfield integration. We're a very small country. Many, you know, we don't have much open space. There's not many spaces to build new things in. So very much our journey has been about a brownfield integration. But of course, if you have large areas that you can develop, greenfield deployments are much easier. There's much less stakeholders to engage with in terms of politics. There's less silos that you potentially need to deal with because you're dealing with a clean sheet of paper. And that's great because the architecture you can put in day one can be modern up front, and it can be agile as well, which means you're kind of trying to future-proof it. So those are really the kind of portals that we look to build based on whether that's greenfield or whether that's brownfield. Now when we look at the use cases that can be applied, and many of the telecommunications companies that ask us today, they say, well, you know, what should we start with? You know, we want to do these things, and there are so many different areas, but typical ones can be, you know, helping like with the smart buildings, maybe the emergency and disaster management, hosting open data portals. Perhaps it's smart surveillance and systems, connected cameras, smart streets with intelligent poles on them that not only is a light, but it has a weather sensor, it has a camera, it has public information boards on it. Smart waste is a very good one as well. A lot of requirements. It's easy to buy things, but of course you need to get rid of those materials. So smart waste is a really important use case to focus on. But of course, again, that's smart utilities, electricity, water, smart health, smart mobility services, smart parking related to that, smart traffic getting people from A to B. Red light violation cameras is a big thing that we're required to do at the moment. Nobody likes tickets, of course, but obviously for public safety, there are more and more governments saying, you know, we have to get people driving a bit slower, and we've got to stop people sort of jumping red lights and things. So a lot of focus around that kind of violation type architecture as well at the moment that we've seen from across the world, as well as smart communications, being able to connect to everyone. This is the latest status information about X, Y, Z, smart kiosks, smart information. Help call pods, etc. All these are the main areas. Now, bringing this all together in that common format is really the challenge for all of us architects out there today, to bring it together in a smart way, including building ourselves that digital twin operations center, that e-government operations center, and that city government operations center. So just this is one of the extracts that I've just made here that I captured some time back. We've looked into our portal and we said, what are the people thinking about us? So taking that data and saying, you know, where are the complaints coming from? You know, what are the kind of issues? How are we doing? What are the complaints that we're seeing? What topic areas are people complaining about? You know, so these are important that we have that kind of pulse of the city, you know, almost second by second, minute by minute. So that we can very quickly adapt to that. Now, using AI, you can take a lot of these and make sense of the data you're receiving and start providing those more predictive and prescriptive outcomes. An example here, this is the opening of the Command and Control Center in Singapore, where, again, I mentioned that it's important for different agencies to be able to share their data between them, to be able to reduce response times, to be able to reduce their overall operating cost. And of course, you know, shared data center, shared services is a reduction then of energy. And so that's just one example of bringing things to life with integrated data that is actually powered by AI. In a bit more of a deeper dive into the infrastructure, you can see typically how an IOC would be structured here. We're taking all the different types of data from IoT devices. They can be microphones listening for abnormal noises, weather conditions, flooding, for example, and taking all the different types of video sources as well and bringing that all into this analytics core. And I'm not going to go into any detail, I'd love to, but because each one of those is a great use case, but bringing it into that analytics core, ingesting, processing, that's really the smart part of our journey as architects in making this real, and then surfacing that through to the people that need it, bringing an understanding in our water services, our electricity services, connecting with our communication services, such as the police, such as the hospital services, security departments, etc., and bringing in all that transportation data as well as the different healthcare services. So this is what we aspire to when we look to have an integrated nation, or when we have to look to an integrated city. And again, just some more. This is actually a snapshot I've done of one of the live portals, whereby we see this is more the emergency management side, where we link the mappings, field communications, all the different assets that are in the field, providing analytics, computer-aided dispatch, call handling, and API integrations to connect to the different subsystems that make up government. And here you would see, for example, that there is a critical stress on one of the bridges, and this is then raising a critical alarm that's being alerted to the relevant authorities with a complete SOP set of processes to make that happen. Again, kind of things that we're using AI analytics for. I think you all know these, but it's always a good reminder that very, very commonly we're looking for disruptive situations, especially around transport, queues on roads, and if we can immediately identify here that this situation is not right, this immediately triggers in our command centers that something is wrong. So we don't have to have someone looking at a picture or waiting for a phone call from someone. We actually know that through video analytics that's happening, but it can also be law enforcement. It can be things like such as social. Perhaps there could be some fighting or something doesn't look right. Bins are overflowing. Let's flag that to the relevant authorities. Let's do more on relief around those traffic junctions, making sure that we're collecting the right data points on the number of vehicles. Are there any compression points that we need to relieve by changing the traffic light sequences dynamically? And of course, any security concerns, left baggage is always something of concern, whether that's an airport or the side of the road. This is all something that AI analytics brings to the table in terms of delivering good cities. So one of the challenges as you build your cities, as you build your nation, is you will have so much choice on what kind of sensors you can buy, what kind of operating systems that support that, what kind of protocols they use. And very often different government departments or different businesses will have their own budgets, and they will go and buy the brand that makes sense for them, which is nothing wrong with that. The problem is when you want to bring all of those services of the city together to be a true digital city, you'll find that you're trying to, create you've got this kind of mishmash of all these different devices and protocols. It'd be a lot better if you could standardize on a framework in the beginning, standardized API, standardized what we call pub-sub architecture models for being able to display different devices and be able to link that to different device queues. And so what happened here in Singapore is we said, let's stop the journey of just having disparate devices. Let's create an architecture, a sensor network itself, where the devices are more standardized, the protocols are more standardized, and how we exchange that data between the government departments. So if I want to install one camera, that camera can be shared between the police, the traffic department, the environment authority, rather than having 3 separate cameras. So that's all part of how to share, right? And without that good governance in place, it's very, very difficult to be able to truly become that smart city, that smart nation. But of course, as you deploy, I mentioned that earlier, as you deploy IoT, you're going to go from hundreds that were manageable to thousands that are becoming, that's starting to become a bit more difficult to manage, to potentially millions of sensors across the city, across the nation, and therefore, keeping an eye on that security and what systems will you use to keep management and update of all those different sensor types and gateways, because they're all operating systems in themselves. Typically they may be a Linux OS, and they'll all need to be patched and managed to some degree. Here was just an example I took of an implementation we did. This is another command and control center where we brought all the pieces together: video, analytics, the command and control, using what we call that city data, bringing all the pieces of data together, using national agencies because we need the number plates of cars to do any matchings, and that security operations center. And that's all in an integrated framework of delivery. And so this is very, very typical what we see around the world, building these command and control centers to provide those outcomes that we talked about earlier. And of course, a lot of that data can be real time, and some of that can be batch. Not everything you need for what you do needs to be actually processed in real time. So you may want to do an analytics AI job in batch model that can run over several days to provide you different types of outcomes that are not real time critical with AI outcomes exactly at that time. It's always very important, if you've got good data, share good data. If it's obviously classified, that's a very different matter, but most data that's created by businesses and governments typically can be shared for the good of society. And please do take a look at, for example, one example with data.gov.sg. Here you will see all the different data sets that actually that show how Singapore's functioning, whether that's environment, education, whether that's technology development, whether that's where are all of our buses and transport. And it's really, really easy to just get started. You can pull it as a CSV, you can pull it in as an API, get post-timer models. So much data is available there for you to be able to use. I mentioned that, about batch information earlier, and I said that whilst it's important to look at, what is happening in the past, what's happening right now, because I need to react to it right now, but also to be predictive. And so what I need to be able to do is, with my data, I need to be able to look for hotspots. I need to be able to say, do I have all my right traffic officers deployed in the right place? Do I have all my tow trucks deployed in the right, based on previous data? And so that's really part of the journey as well, becoming, not only looking back at what happened, rear view, what's happening now, respond and act, but being smarter to be able to deliver smarter outcomes by being predictive and prescriptive in nature, if you can achieve that as well. And so just some real examples there of some heat maps that we're seeing from different agent and police deployments based on different hotspots and troubles that could be occurring. A topic close to everyone's heart, looking forward to when this goes away, sooner rather than later, pandemic management, to be able to understand where outbreaks are occurring. And again, all pandemics are data in one form or another when you're collecting this. What is happening? How many people are infected? How many people are being tracked? How many people? Which hospitals should people be deployed to? Start to spot the trends and say, based on all this data, I know what's going to happen next, or I have a good feeling of what's going to happen next. So that complete life cycle of pandemic management. And so we've had to respond to many different requirements from around the world from our customers, including such things as, like India, for example, was where is the closest oxygen bottle, what are the supplies of the oxygen bottles within different hospitals. So those are all projects that we've had to implement, and this is all based on data. It's all making smart use of that data as well. The same token, but huge amounts of data is being created by traffic systems. We want to be more predictive. Here is a picture you can see. I snapshot this the other day of where are the buses in Singapore, right? Where are the hotspots? Is there bus bunching where you get too many buses close together and they're not separated well enough? So we want to dynamically separate those buses so that they keep according to their schedule. Or perhaps they've broken down, so we're constantly using message protocols to be able to collect in real time, by the second, where every bus is, and actually what's happening. And again, using this data, we can develop smarter models based on how many passengers we picked up. Do we have the right buses for the right routes? Should we use a single-decker bus or a double-decker bus? All this is important data for whether that's business efficiency or environmental efficiency. And I would say that we spend a lot of time in this area of understanding what's happening from data and building these heat maps and trying to make sense of what we see. I won't go into detail here, but you will have the PowerPoints later. This is really just what we call that cognitive architecture that I mentioned earlier about how we process that data core, how we provide the automation, and how we provide the artificial intelligence and cognitive algorithms that basically run against that to deliver those outcomes that we talked about earlier. I mentioned digital twin. Digital twin is really one of my pet subjects right now. I think it's amazing. And if you haven't used it yet, you must use it and start looking to how you can use it, because it's all linked to the AI as well. The ability for you to take a analog model, anything that exists in reality, turn that into a digital model, whether you're building for public housing, whether you're doing emergency simulation, what would happen if, whether I need semantic information for my planning of buildings, whether I want to know what impact something has, like adding more cars, adding a road, shutting a tunnel, whether I need to figure out where my solar panels need to be placed on my buildings, and how am I doing? Am I keeping to my goals of energy and management and efficiency? And again, I mentioned earlier about the transportation, but am I achieving those goals if I make changes to these different routes or to these traffic lights? Will that really actually deliver something useful? Because it's all about sustainable outcomes, right? It's all about reducing travel times, and it's also about switching eventually from diesels and petrol cars to electric vehicles as well. This all can be simulated in a digital twin model. Here's some screenshots that we've done for you, where we've looked at demand mobility, we've looked at the traffic flows, we've looked at the air pollutions, for example. Where are the hotspots happening right now? What are we doing there? Where's the noise within cities? How can we build better that reduces noise of transport and industry? Where can we best place our wind farms and our solar? Where's all the energy hotspots being taken from? What happens with global warming and flooding? Give me a predictive model of what needs to change in my city or in my country. And what is the effect on health and livability indexes as we make changes and design changes? And that zero emission mobility, for example, as we switched in Singapore from the diesel to the electric trucks, how would that change the environment? Where would we need to install all our electricity charging points? Would a bus be able to go as far as one that would today on a full tank of diesel? So all of these need to be part of that data gathering model that you need to build as a digital twin. A quick example here of a city that I mentioned earlier. This one is Vizag city in India, where all the pieces of government, where all the IoT is brought together in an intelligent way, ingesting using artificial intelligence to be able to deliver smarter outcomes for the city. And really, I mentioned right at the beginning, if you recall, I talked about stakeholders, and there's nothing more important that technology we know. I love technologies, it's easy to deal with. But never forget, at the end of the day, the different stakeholders that are involved in changing an agency or a city or an entire nation. And this example is the nation of Thailand, where we brought the different government officials together from different agencies that represent their data as such. And we said, how do we all work together? How do we build a framework for Thailand where we can bring all this together and deliver cognitive AI outcomes? So that was a workshop we did. That was actually in March 2020. I think a month later, I stopped traveling around the world. I stopped traveling to Sri Lanka, which was a shame because I have a nice little house there. And yeah, so this is really a very important picture. Bringing people together is what matters, because the technology you can solve, no problem. You're going to see so many solutions today about how to do that. But people are the most important part in your transformation. And finally, getting together, building those rapid design workshops, getting the whiteboards out, the pens out, building those frameworks so that you have strategic clarity, make sure you have the right leaders in the room, the right stakeholders. Don't overcook a vision. I mean, make sure that you can achieve it. You know, there's no point putting something in that's just not achievable. Make sure that you can achieve it, deliver it, and build on that success. Right? Be very razor focused on the users themselves. That's really important. And future-proof your solution as much as possible, whether we're talking about agile, whether we're talking about standardized message protocols, architectures, and data frameworks. Keep developing those skills. You're going to need them faster and faster. And don't forget quantum computing is coming as well, so look to that. But having great people around you, many of the people on this call today, you know, the supplier partnerships, they're part of that journey as well. And make sure that you really can get the benefits. If you say that you're going to deliver a business outcome, you're going to deliver a return on investment, make sure that you do that, because that then you can plow back into your next success. So it's a big journey. I've really enjoyed speaking to you. I wish I could be always in front of you today. I do miss the people interaction. You can contact me, Martin_Yates at Dell.com. And with that, I wish you a super success in the remaining conference that's ahead of us, and wishing you lots of learning. And I really do hope to be able to hear from you soon and learn about all of the successes that you're actually having within this group today. And so with that, I say thank you very much. And if there's no questions, I will hand back to the organizer. Thank you very much, and take care now.